Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you've come to the right spot, so go ahead and click the subscribe button. That said, let's get into the current video. In a previous video, I talked about the integrating factor, which you'll learn about in your differential equations course, and how to use it to solve a first-order linear differential equation. In this video, what I want to do is show you, well, where does that come from? Where does the integrating factor come from? Well, consider the following. Let's say I've got my differential equation in the proper form. So y prime plus p of t y is equal to q of t, right? This is the form for which we will use an integrating factor. Well, what I want to be able to do is multiply by some sort of a function. The function being mu. I want to be able to multiply both sides of this, so I get the following. Mu y prime plus mu p of t y is equal to mu q of t, right? What I want to do when I use an integrating factor is I multiply both sides by that. Then the goal and the hope is that I can rewrite this side as the derivative of a product. And what I took the derivative of is mu times y. So I want this whole left-hand side to be the derivative of mu times y. Okay? So then that's going to be equal to mu q of t. So basically I'm just going to kind of ignore the right-hand side. That's just part of the differential equation. I'm focusing on where does mu come from. Well, if I use the product rule on these two terms here, let's just expand that. That will be mu prime y plus mu y prime. Now, that means that those two terms would have to be the same as those two terms, right? So I would have mu y prime plus mu, I'm just going to write that as p y, is equal to, down here, mu prime y plus mu y prime. Notice that both sides of this have a mu y prime, so I can cancel those. So that means I've got mu py is equal to mu prime y. Okay? Now, we're going to assume that y is non-zero, because remember, y is the solution for the differential equation, so I want to assume that my solution is non-zero. Non-zero means I can divide by it. So that means I've got, and I'm going to rewrite it this way, that means I've got mu prime is equal to mu times p. Okay? So the integrating factor that would work to write this as a product of a derivative, or a derivative of a product, would then satisfy this relationship right here. Well, let's divide both sides by mu. So I've got mu prime over mu is equal to p. Okay? Now, what if I integrate both sides? If I integrate both sides, then notice that this is equal to, well, actually, if I do this first, I'm going to say that's the derivative of what? The natural log of mu. Right? Because if I differentiate the natural log of mu, it's the reciprocal of the argument times the derivative of the inside, which is mu prime over mu. Right? Now integrate both sides, and I get the natural log of mu is equal to the integral of p. And that's with respect to t. Solve that for mu means to get rid of the natural log. I'm going to exponentiate. So therefore, I get the mu is equal to e to the integral of p dt. And this is the infamous integrating factor that, again, you will learn about in your introductory differential equations class. So once again, what do I multiply this linear first order differential equation by so that the left-hand side becomes the derivative of a product? Well, that function going through these steps here, we can see that it has to be e to the integral of p of t dt. Thank you for watching. Please consider subscribing.